Okay. Now, today I will go to another technique, that is a Fibonacci method. That is a very nice method, and mathematicians they are really like it, and I will just explain this method for you. Now, whole the Fibonacci method is dependent on the Fibonacci series, that is the beauty of it. And before going to that methodology, few things I will just like to mention here, that for the Fibonacci method there are we need to know that the initial interval of uncertainty where optimum may lie, and function must be unimodal within that it should be there, otherwise this method does not give me the optimal solution. Okay. The second thing is that we need to know that how many number of experiments I want to do, that I need to know beforehand, otherwise I cannot complete my process. That is why n should be known to us. N need not to be even, it can be odd also, because in the dichotomous method, as we have seen, we had the n even number of, because at each iteration we were getting the even number of observations, but here that we are relaxing that in each iteration we are getting one, and I know that if 10% accuracy I want, I will have to do this many number of experiments. If 5% accuracy I want, then I need to do this many number of experiments. That is why it should be known to us. And this method is totally dependent on the Fibonacci series. What is Fibonacci series? All of us know. F0 is equal to 1, F1 is equal to 1, F2 is equal to 2, that means sum of the previous two. F3 is equal to 3, F4 5, F5 8, let me stop here, F6 13. Okay. I can go further even, F7, F8 etc. And for each iteration I will call one Fibonacci number at a time. That is the nice thing. And what is the understanding for the Fibonacci series? Fn must be is equal to Fn minus 1 plus Fn minus 2. Alright. This is the thing. Now, I am coming to the process. Just this is my initial interval of uncertainty. Alright. Now, the first approximation, if the n is the number of experiments I need to do, first you need to listen the process, then why I am considering that term, that you will understand once you will learn the process in detail. That is why the first point would be a plus f n minus 2 divided by fn into L naught. L naught is the initial interval of uncertainty, where I know that the optimum may lie. Okay. Now, the first point x1 would be is equal to a plus f n minus 2 divided by fn into L0. If I have to do 6 number of experiments, then it would be is equal to f4 by f6 into L naught and a. This is my x1. Okay. I will go to x2, because at the initial level I will find out 2 approximations at a time. After that I will do 1 at a time. I will find out x2 is equal to b minus fn minus 2 by fn L naught, b minus fn minus 2 by fn L naught. That can be written in other way. Just you see, b minus fn minus 2 can be written as, just from here, fn minus fn minus 1 divided by fn L naught, because we know that fn is equal to fn minus 1 plus fn minus 2. I am just substituting this value. That is why from here we are getting b minus L naught, alright, plus fn minus 1 by Fn L naught. What is my B minus L naught? L naught is equal to B minus A plus this term. That is why BB will cancel, I will get A plus Fn minus 1 by Fn L naught. Did you get the beauty of using the Fibonacci number? Once I am getting the first one as A plus Fn minus 2 by Fn into L naught, and the second I am getting A plus Fn minus 1 by Fn into L naught. In other way also I can say that B minus Fn minus 2 by Fn into L naught. I got 2 experiments up to this. That is why my next interval of uncertainty would be L2. How much L2 will be? That is the question to you. How much L2 it would be? You see, in one side I am taking this term with addition with A, and in the next I am taking this the same term I am subtracting from B. That is why this term is the guiding term for me. Okay, and next interval of uncertainty would be L naught minus this term, because as you have seen in the dichotomous search, okay, the same thing we will discard a portion. How much portion I will discard? I will, after discarding a portion, I will get the new interval of uncertainty as L naught by this one. Actually, there is a name of it. This term is being named as L2 star. That is why the method tells me that I am having L naught, the first interval of uncertainty. Okay. Then I will find out L2 star as Fn minus 2 by Fn L naught. I will subtract, I will add, and I will get the new interval of uncertainty, and that would be L2 would be is equal to L naught minus Fn minus 2 by Fn L naught. In other way, L naught minus L2 star. Clear? In the third, I will find out L3 star. And what is the process? In brief, I am just telling to you, then you will understand. Just to see, initially I was getting x1 and x2, okay, and I am saying that take 2 points x1 and x2, which is L2 star distant from the both ends of that interval, because I am taking A plus L2 star, B minus L2 star. That is why the guideline is that the current solutions are L2 star distant apart from both the ends. Okay. Next, we will eliminate the region using the region elimination strategy. I will get the new interval of uncertainty as L2. Then I will go to L3, because I will take in the next iteration initially 2, after that I will take 1 at a time. Okay. I will calculate L3 star, and my guideline is being said that in the new interval of uncertainty take point so that the current solutions means the new solution x3 and the previous solution from the previous stage, both the solution must be L3 star distant apart from both the ends. Then I will find L4 star. I will say current solution must be L4 star distant apart from both the ends. This way I will proceed. In the jth iteration, I will get Lj star as this value, and you see the beauty, the L2 star was Fn minus 2 by Fn L naught, but here L3 star is equal to Fn minus 3 by Fn L naught. L4 star is Fn minus 4 by Fn. Like that, how far I can go? I can go up to n, because at the time of n I will have Fn minus n, that is F0 by n. Okay. That is why I will find out. That is why let us see what is happening in the next. In the next, we are getting L naught, that was the first interval of uncertainty. Second interval of uncertainty was L naught by L2 star minus L2 star. Did you understand? The third interval of uncertainty is L2 minus L3 star, because at every time I am reducing L2 star, L3 star, L4 star, L5 star further and further from the whole interval, and ultimately at the end after jth iteration we are getting Lj minus 1 minus Lj star. Then if I ask you what should be the nth interval of uncertainty, can you tell me what should be the size of it? Ln. That is very, just if you see the pattern from there you will get always the nth interval of uncertainty would be 1 by Fn, because we know F0 is equal to 1. Okay, that is the beauty of it. If I want to have 6 number of experiments, I know I have to do 6 experiments beforehand. That is why my last interval of uncertainty, that size would be, nth interval of uncertainty size would be is equal to 1 by Fn, okay, 1 by Fn into L0 all the time. Clear? In this way, this is the beauty. If I just show you the calculations, then you will understand better. Let me consider L2. L2 is equal to L0 minus L2 star. What is my L2 star? L2 star is equal to L0 minus Fn minus 2 divided by Fn L0. Alright. This can be even written as Fn minus 1 by Fn L0. There is no harm to write it in other way. Go to L3. L3 is equal to L2 minus L3 star. What is my L2? L2 is equal to Fn minus Fn L0 minus Fn minus 3 by Fn L0. Okay. We know that this is the previous, this is the next. Then Fn minus 1 is equal to Fn minus 2 plus Fn minus 3. That is why if I take common L0 by Fn, if I take common, I am getting Fn minus 1 minus Fn minus 3. That is nothing but Fn minus 2 by Fn L0. Just look at the pattern. L2 is equal to this one. L3 is equal to this one. Okay. Let me go to the jth. Lj is equal to F n j minus 1 divided by Fn L0. Got it? Ln is equal to, if I go further, Ln would be is equal to F n minus n minus 1 divided by Fn L0. This is equal to nothing but 1 by Fn L0. Okay. Now, if I want, just you see, if I want 10% accuracy, then the half of the Ln by L0 as I did before, that must be 10 by 100. Alright. Here what is Ln by L0? This is equal to 1 by Fn, must be less than 0.1. In other way I can say Fn must be greater than, this is 0.1 means 0.2, that is 1 by 5, then Fn must be greater than 5. Okay. Now, if I just look at what is the minimum number I will get to get Fn greater than 5, n is equal to 5. Alright. That is why I have to do 5 number of operations. The process is simple, I told you, but for example, I want to have 5% accuracy. I can have 7%, I can have anything. 5% accuracy, then half of the final divided by initial must be less than 5 by 100. Alright. What would be the value for this? Again, half into 1 by Fn is less than 1 by 10. 2 won't be there. 1 by 10. That means Fn must be greater than 10. If I again see the Fibonacci series, Fn is greater than 10, the minimum value must be 13. That means I need to do 6 number of iterations. That is the beauty of it. Okay. Now, let us take one example for doing these calculations. Okay. Now, if I just see the pattern of it, of the function, this is the pattern. What did you see? That function is unimodal between 0 to 3. Where is the mode? It is not much visible from the figure, okay, but you see, I want to have 5% of exact value. That means, as I was mentioning, I need to do 6 iterations. Let us start the process for calculating this, for going for the further method. Okay. Now, I have to do, I want this value once again, that is why let me quickly write it down. F2 is equal to 2, F3 3, F4 5, F5 8, F6 13. I will reach up to F6. I have to. Now, the first approximation, x1 is equal to a plus Fn minus 2 by Fn L0. Here the value is coming as 0 plus Fn minus 2 means n is 6. That is why 5 by 13 into 3. This value is coming as equal to 0.1846154. Okay. And I will take x2. This is equal to b minus Fn minus 2 by Fn into L0. That is why this value is coming as b is equal to 3 minus 5 by 13 into 3 is equal to 1.153846. I will get 2 approximation. Let us find out the value for 0, 3, x1, x2 this side, x1. Alright. If I want to have the functional values are coming at 3, it is coming 7. At this one, it is coming 7.17 in the positive side. Since the space is not there, I am considering the positive side here. Alright. 7.1775. x2 the value is coming far greater, 8.5613, and this is coming much more value, 13. What did you see? Where the optimum cannot lie at all? I am considering for the minimum value. These are the higher values. That is why optimum cannot lie at all from this to this. Okay. My new interval of uncertainty then what would be? It would be from x2 to 3. If we just calculate new interval of uncertainty, L2 will always come as L0 minus L2 star, that is 3 minus L2 star was coming as 1.846154. Okay. This value you will get always. Even from the picture, if I just find out, I will get this interval size will be this much in the next. Okay. I will do the next iteration. I will calculate L3 star. L3 star would be is equal to Fn minus 3 divided by Fn L0. Here my n is equal to 6. That is why Fn minus 3 would be 3 by 13. Okay. 3 by 13 into 3. And I have to take, I am having 2 points here. One point is x3, x2. What is the x2 value? 1.153.846 and another 0.3. Okay, I have to take the third point in such a way that the current observations are L3 distant apart from both the ends. Very nicely I will see that this value, the new value x3 will come as 3 minus L3 star. This value will come as 3.07692. Alright, and if I just see 2.307692, and previously I was having another point that was 1.846164. You will see this distance and this distance always will be L3 star. I need not to calculate this one at all, but it will always come as L3 star. Alright. Again I will do the next iteration, L4 star. Again I will find out. Now let us find out the values. I will show you all the values together just to see the values. Now these values were coming that from the first we were discarding from 0 to this one because this was the higher value for me. In the next iteration, when I am reaching 3 to up to this, just one second. If I just see the functional values, it is coming 7, 6.78, 7.17 and 8.56. These are the functional values and these are the points within that interval. This was 3, this was the new x3, this was x2, this was x1. All the values are there. And what is the trend? Trend is coming as that here is the higher values. That is why since there is only one mode, at least we are sure minimum cannot lie here. We will go to the, we will discard this interval 1.15 to 1.84. That is why new interval of uncertainty would be 3 to 1.846154, and this size would be always L3 would be is equal to L2 minus F3 star. This will be always will be is equal to whatever L2 value I was having previously, that minus this. You check it. Alright, this is the value you need to check. Then I will get the functional value in the next iteration. Okay, I have given with the rate the approximation. This is x1, x2, x3, x4. Okay, and you see again the function pattern. You see function pattern is just increasing functional values. Again we can conclude that optimum cannot lie within this. That is why we will discard this interval from 1.846 to 2.307692. Then we will do the next, this one. Okay, and you see how many points we got it through this iteration. We got total 6 points, 1, 2, 3, 4, 5, 6, and ultimately you see always you will see both the values will come same, and that can be declared as the optimal solution. Now this is for the 5% exact value. If I want to have the 10% exact value, in that case my process will change. What I have to do? I have to consider 1, 1, 2, 3, 5 up to 8, because n would be is equal to 5 there. That is why a will be x1 would be is equal to a plus fn minus 2 by fn L0. That means this is equal to 0 plus 3 by 8 L0, and x2 would be is equal to 3 minus 3 by 8 L0 is 3 here. Alright. In the next case, I have to consider L2 star was this one, fn minus 2 by fn. L3 star would be is equal to fn minus 3 by fn, that is 2 by 8 into 3. Alright. The next one would be 1 by 8 and again 1 by 8. If I just proceed in this way. Now, if I have to do more number of experiments, what is the thing is that if I want to have more number of experiment means this is not really required for the Fibonacci method, because the Fibonacci method, this is the n value, this is the minimum n value for getting the optimal solution. Okay. And that is all for today, and in the next class I will do the golden section method, and I will tell you whatever methods you have learned till date, the region elimination technique, which one is better and which one is the best one and why. All this logic that totally depend on the interval of uncertainty, size of that, as well as the number of iterations. If the number of iterations are less, I will be very happy if I get the same optimal solution. Let us consider another example. We are considering the same function, but here we are only considering the 10% of exact value. 10% of exact value means, as I said before, half ln by L0 must be less than 10%, that is 10 by 100. Okay. That is why here if we just I did the calculation before that we need to do minimum 5 number of experiments. Alright. And here the initial interval of uncertainty is 0 to 3. That is why our first table is this one. This is the functional value at 3, this is the functional value at 0, and in between we are considering 2 points. 2 points, how far it is where we will locate these 2 points, that will be L2 star distant from 3 and it is also L2 star distant from 0, alright, equal distance, that the distance is 1.125, alright. From 3 also the same. Let us just to see this is the functional value. If this is the functional value, just look at the trend of the function 7, 7.14, 8.6, 13. That is why we could see that functional value is increasing from 7 to 0. We are finding out the minimum value. That is why we can say that there cannot be any minimum in between 1.125 and 0, because the trend of the function is increasing. Then what we will do? We will again take new interval of uncertainty as from 1 to 1.125 to 3. Again we will consider L3 star and we will consider 2 points L3 star distant apart from these 2 points. Just you see the trend of the function. This is the second table, alright. And what you can see that functional value is decreasing, then increasing further, again increasing. That is why you are sure that there cannot have any minimum in these 2 points, 1.875 to 1.125 to 1.875, there cannot have any minimum. That is why new interval of uncertainty we can define from 1.875 to 3. That is why let us consider 2 points, 1.875 to 3, in between again L4 star distant apart from both the ends, alright. Just to look at the function, functional value is almost converging here, because it is coming 6.8, because functional value is decreasing, then slightly increased, again increased. If we expected, if we do the next iteration, we will get the optimal solution. We know how many operations we need to do in Fibonacci method. That is why again we are eliminating the region, here cannot have any minimum, functional value is increasing, that is why we are doing this, and we could see 2.625, both the points the functional values are almost same. Alright, that is why we can declare this is the optimal solution of this problem. And if I just want to revisit the whole iteration methods, then we could see that how many points we found. We started from 0, 3, these two. First we found out 1.875 and 1.125, then again 2.25 we found, then again 2.625, and we conversed here. Alright, we are getting 4 points from here. Alright, and that is all about the Fibonacci method. Thank you for